Hello friends, welcome to the another tutorial of basic electronics module. So in this particular session, we are going to build some circuits and perform the different activities. In this chapter of basic electronics module, we will gain some practical knowledge and also hands-on activities about how to make LED glow, how to interface a push button, how to connect a slide switch, and also how to turn on RGB LEDs. So as you all know that in the previous lecture we have seen the Tinkercad application, that how you can make a circuit in Tinkercad and how you can make your own account. So after seeing the basics of Tinkercad and the basic icons usage in this particular activity session, we will see that how you can make the different circuits on breadboard also and also in Tinkercad. So as you can see that this particular chapter is divided into four different parts. In the first part, you will be introduced to the different activities and how to turn on LED. So your first activity would be how you can turn on a LED. In the second part, you will see a push button interface, that how you can control LED using a push button. In the third part, you will see the different connections which are series and parallel, means the series connection for different LEDs and parallel connection for the same LEDs. Then in the fourth and last part, you will see the interfacing of slide switch, means how you can connect a slide switch to control the devices, and also you will learn that how you can connect a RGB LED. So the flow of activities here is, the flow of activities is given, that how your activities are gonna start. In the first part, we will see the introduction to the activity and briefly the introduction to the components. Then in the second part, we will list the hardware required to build a particular circuit. And the third part, we will see the circuit diagram. In the fourth part, we will see the circuit connection steps. And in the last fifth part, we will see the applications of the circuit we have built. So let's just start our first section, which is introduction section. So today in this session, we will connect different components like LEDs, batteries, and push buttons on breadboard, and also we will see how you can connect these all components online on a software called Tinkercad. So how you can make all the circuits in the Tinkercad, you will also see that, and make LED glow. So how you can make a LED glow and also control them with pressing push button. So you will interface a push button to control the switching operation of LED. We will learn how to connect LEDs with battery and breadboard, and as a result of this connection, we will see the LED turning on and off. Here we will list the components required for a particular connection. Then one by one we will connect them with each other on a breadboard. So let's first start a basic activity, and then we will go for a deep dive into the world of circuit connections and electronics. So let's just briefly discuss about our components which we are going to use to build different circuits. The first and common is breadboard. So a breadboard is nothing but it is a component which is used to prototype a circuit or to test a circuit. So rather than soldering them for permanent, cause we have to first test our circuit. So we use breadboard to mount different components onto it and perform our experiment. Then after, there are jumper wires. So jumper wires are nothing but they are used to connect all the components with each other, and they also provide a conducting path for current to flow through. So it gives a current path to flow through different circuit elements. So they are used to connect different components. Then after, there is a resistor. So a resistor is a passive to terminal element which is used in circuit to limit the current entering to LED to protect the LED from overcurrent. So here we are using resistor in a circuit to protect the LED connected in the circuit from overcurrent. So a resistor is nothing but it is a two terminal passive device. Battery to provide voltage to the circuit, means battery is there to provide power to the circuit. Then after, there is LED. So now this LED is an output device, means onto which we are going to see our output as turning it on or turning it off. So LED is a device which emits light when the current passes through it or through its terminals. So whenever there is a current flow through its anode and cathode, the LED, this diode emits light rather than heat. Then there is a slide switch. Now this slide switch is used as an input device here. So, an input device used to turn on and off the external circuit connected to it. So, we are using slide switch to turn on and off both the devices connected onto both the side of it simultaneously. Then RGB LED. So, RGB LED is a one type of LED which we have discussed in the dedicated section of LEDs. So RGB LED is one of the different types of LEDs, and this is also an output device and used as a 3-in-1 LED element to illuminate red, green and blue light. Then after, push button. So push button is also your input device used to interrupt the current through the components, or you can say to interrupt the circuit current, turning it on and off the external. So this is a breadboard's representation, that how the breadboard's internal terminals are connected. So from the uppermost part and the lowermost part, this one and this one. So in this particular section, the positive sign from here to the positive sign here, the entire row is connected internally. So this row is horizontally and internally connected. Similarly, this particular row from here to here, all the holes are connected internally. So this row and this row, they are horizontally connected. Now similar for this module also, from here to here, all these row all these holes of row, this row only blue, which is in blue color, they are connected internally, and the holes which are in red color, they are connected internally. So the uppermost part and in the lowermost part, the holes are connected internally in horizontal formation from its very first hole to its very last hole. But while in the middle part, in the middle area, this middle area also is divided in two different parts. The one is here and the another one is here. And in the middle part, only these five holes from here, one, two, three, four and five. So this column only, which is in green color, they are connected internally. So the holes here are connected in vertical manner and holes here are connected in horizontal manner. So from here to here they are connected internally. Similarly, these holes are connected in in vertical manner from 1 to this 5. Now this section and this section, this both are separate sections. So from not from here to here they are connected, only from this first hole to this fifth hole. Similarly, for from this first hole to this fifth hole, they are connected vertically. Similar for all the columns. So in this type, all the holes are connected internally in vertical manner, and in upper and the lowermost the holes are connected horizontally and internally. From here we are beginning our activity session. So we will start learning about how to build different circuits, and the software we would require for each and every circuit is Tinkercad. Now let's first see how to turn on LED. It is a basic and the simplest activity of all the activity session. So this is the primary circuit to learn and to grow from here. To build this particular circuit, you would require a breadboard, a 9-volt battery, some jumper wires, a LED, and one resistor. This is the circuit diagram of your circuit, that how it looks like after the completion of connection. So first collect all the components and place the breadboard and battery similar shown in figure. Now connect the negative terminal of battery to the negative rail and positive terminal of battery to the positive rail of breadboard using a black and red jumper wire respectively. Now place the LED onto the breadboard, something like this. Now this is the anode and this is the cathode. Now let's first say that how you can differentiate between anode and cathode. As you can see that the anode is one which has some partial fraction, and cathode is something which is a straight one, while your anode terminal is partially bent and is the longer one from both of them. So cathode is one which is shorter and straight, and the anode is one which is partially bent and long one. So connect the longer one or bent one, which is anode, with the positive rail of breadboard using a red jumper wire, and connect one terminal of a resistor to the cathode of the LED. Now the remaining terminal of the same resistor connect to the negative of breadboard using a black jumper wire. So anode is connected to the positive rail of breadboard, which is going directly to the positive terminal of battery. So these jumper wires are used to extend the circuit, and it is indirectly it is connected to here, and from here it is connected to battery. So your anode of LED is connected to positive of the battery or supply, and the negative of your LED is connected to the negative terminal of battery in this manner. So here your circuit is completed. As soon as you connect the red black wire or cathode wire, you will see that the LED is turned on. If you have connected red LED, then your LED will emit red light, or you can see the red visible light. Whichever LED you have connected, you will see the same light of it. So this is a connection diagram, and these are the steps to follow when you are making a Tinkercad circuit. So first of all, on the home page of Tinkercad, click on the new then circuit and rename the project as turning LED on. Collect all the components from component section. Connect the positive terminal of battery with the positive rail using jumper wire, and the negative terminal of the battery to the negative rail of a breadboard using a black jumper wire. Connect anode of LED with positive rail of breadboard using a red jumper wire, and connect the cathode, which is the negative terminal of LED, with one of the 470 ohms resistor using a jumper wire. Connect the remaining terminal of the same resistor with the negative rail of the breadboard using a black jumper wire. So your circuit connection is done and you are ready to see the result of your first ever project. So this was a simple LED turning on project. Now let's move forward to our second part of our session, which is interfacing push button. Means you are interrupting the current flowing through LED using a push button. So this is nothing but a controlling of LED using a push button. Here in this activity we are going to control the LED using a push button, such as we use a switch to turn on and off the different appliances at our house, office and commercial area. So what is a push button? A push button is a simple switch mechanism used to control some aspect of process or a machine. So to interface your push button, you would require a breadboard, a 9-volt battery, some jumper wires, one LED, one resistor and one push button. So this is the circuit diagram of your circuit. First of all, connect all the components and place the battery and breadboard. Connect the negative terminal of battery to the negative rail of breadboard and positive terminal of battery to the positive rail of breadboard using a red and black jumper wire. Now place your LED something similar to this circuit diagram. I am here using a green LED. Now connect the cathode. First we will connect the cathode connection. So first connect the cathode of LED with a resistors one, any of one. See here there is no tension of polarity. So you can connect either of the terminal of resistor with cathode of LED and the remaining terminal of the same resistor with the negative rail of breadboard using a black jumper wire. Now here we are seeing a push button. So for you, push button is something new. So what happens in a push button is these vertical are connected internally. If you can see, it has some naming terminology. Say it is 1A, then it would be 1B. If we are saying it is 1B, then it is 1 2B and this is 2A. So these two are internally connected. Similarly, these two are internally connected, means this terminal and this terminal. Both the legs are internally connected and also this both are internally connected. So connect here first time in vertical manner. So place a push button and connect one terminal of push button with the anode of LED and the vertical of this terminal. So this would be a diagonal terminal, sorry, no vertical, diagonal. Use another diagonal terminal. So this diagonal terminal, connect it with the positive rail of breadboard using a red jumper wire. So here your push button interface or controlling of a LED with push button circuit is done. Now it's time to check your experiment or check your project. So what would you see that after connecting it with positive terminal or positive rail of breadboard, you'll see that your LED is not turned on yet. So your LED is in the off state, right? But in the previous project, as soon as you connect both the terminals of your LED, you see that your LED turns on instantly. But in this time, your LED is still in off state. Now, here is the here is the function of push button comes. So now you press the push button and you will see your LED is glowing. So this is the function of push button. So when you press the push button, you will see that your LED is turned on As soon as you unpress the similar push button, your LED would be turned off. Hence, it is controlling the switching operation of your LED. Hence, it is your input device and it is giving you output. Hence, it is your output device. So, this is how you can control any device using a push button. Now, push button is a device or is a type of device which requires power source. It requires power source to function. If you are not connecting it directly with the power source, it won't be able to operate. So in order to operate it as an input device, you will have to provide it with a supply necessarily. So here you are giving it a supply, and after pressing it, it will have a conducting path from here to here, and the current will flow through then LED and then register and then in ground, and your path is completed and hence your LED turns on. Now these are the connection steps for Tinkercad circuit. Now first of all, click on the Tinkercad and click on create and then circuit, and then rename your project as controlling LED using a push button. Select all your components from component section and the positive terminal of battery to the positive rail and negative terminal of battery to the negative rail of breadboard via black and red jumper wires respectively. Now connect the cathode of LED to the ground via 470 ohms resistor. Connect the anode of LED to the 1A terminal of push button and 2A terminal of push button to the positive rail using a red jumper wire. Here the circuit connection is done and now you are ready to simulate your circuit. So click on start simulation and you will see your LED is not glowing. But when you press the push button, you will see that your LED is turned on. So this is how your practical for turning on LED using a push button is done. Now let's move forward to our third practical or third activity, which is LEDs connected in series and parallel. So in this particular section you will see series and parallel connection of LEDs. So first is LEDs in series. When the element shares only one common node and the current flowing through them is similar, then they are said to be connected in series. So this is the series connection definition which also follows in this particular section. So your LEDs would share only one common node, but the current flowing through all of them would be same, and hence you can say that your LEDs are connected in series. So hardware required for this particular activities are a single breadboard, a 9-volt battery, some jumper wires, 3 LEDs, one resistor. So this is the circuit diagram of your LEDs connected in series. First of all, collect all the components, place your breadboard and then your battery. Now connect the negative terminal of battery with the negative rail of breadboard using a black jumper wire and positive terminal of battery to the positive rail of breadboard using a red jumper wire. Now place a red LED, then yellow LED and then green LED similar to shown in figure. Now connect the cathode of red LED. Connect the cathode of red LED with a negative of breadboard using a resistor. So place a resistor in between. Connect the one terminal of resistor with a cathode of LED and the remaining terminal of the same resistor with the negative of breadboard using the black jumper wire. Now connect the anode terminal of red LED with the cathode terminal of yellow LED. This is how this red LED and yellow LED shares only one common node, which is here. Now connect the anode terminal of yellow LED with the cathode terminal of green LED using a wire. Similarly, they are sharing only one node, which is this. Now connect the anode of green LED with the positive rail of breadboard using a red jumper wire. Here your circuit connection is done for series connection. So as you can see that all the three elements, see these are the three elements which are in series. The red LED, yellow LED and green LED. These are the three circuit elements which are connected in series, and how you can see that, because all the equipments or all the devices share only one common node. They both share this common node and these are sharing these common node. And also from here, let's just see these, let's just say this is the starting point. Starting from here, going here, sorry, here, see your current is flowing through this path. Hence, your current has only one path to flow through each and every element. Means the current entering from here lives only here. So there is no alternate or other path for current to flow through. Hence, this connection is known as series connection. This and this. So this is your series connection. Now these are the circuit connection steps when you are making circuit in Tinkercad. So in homepage of Tinkercad, after clicking onto Tinkercad, it will appear its basic interface. Then click on the home page of create button and then circuit. Then rename your circuit as LEDs in series. Collect all the components from component section. Now for series connection, of these three LEDs, connect the negative terminal of cathode of red LED to the negative of breadboard using black jumper wire and resistor, and the remaining terminal of the same resistor to the negative terminal of breadboard via a black jumper wire. Now the anode of red LED is connected to the cathode of yellow LED. The anode of yellow LED is connected with the green LED, and the anode of the green LED is with positive terminal of battery using a red jumper wire. So series connection of these three LEDs are done here. Now your circuit is ready to simulate. Click on simulation button, start simulation button, and you'll see your three LEDs are turned on. Now this series connection is used where the same current flow is required. In series connection, the voltage across each component gets divided, while current flows through the same path, hence it is same in all component. So, this series connection is in your home appliances, or whether you can say in the each and every connection of switch and element, particularly whenever there is a switch particularly dedicated to a component, then that connection is in series. So this was a series connection. Let's see LEDs in parallel. So what is a parallel connection? When the elements or devices share two or more common nodes and the voltage drop across them is similar. So in series they share more than one nodes, more than two nodes, and the voltage across them is similar. While in case of series connection, they share only and only one common node and the current between them is similar, or current flowing through each of the device is similar. In the parallel, the voltage across them is similar. Then they are said to be connected in parallel. So which are the hardwares we are going to require is first a breadboard, is 9-volt battery, some jumper wires, 3 LEDs and 3 resistors. So in this activity we are going to need 3 resistors. So this is the circuit diagram of your LEDs connected in parallel. First of all, collect all the components and place the battery and breadboard. Now connect the negative of battery to the negative rail of breadboard using a black jumper wire, and positive terminal of battery to the positive rail of breadboard using a red jumper wire. Place red LED, then blue LED, and then yellow LED, similar to shown in figure. Now, in this parallel connection, we would connect cathode of all the three LEDs with the negative rail of breadboard via a resistor. So, place three resistor. Now, place first resistor at the cathode terminal of red LED and the another terminal of that resistor with the black jumper wire. Now, similar for this to place resistor such as its one terminal is connected to the cathode of blue LED and the another terminal of the resistor to the negative rail of breadboard. Now place all these three resistors similar to these steps. Now connect the anode of all the three all the three LEDs with the positive rail of breadboard. So connect the anode of red LED with the positive rail of breadboard using red jumper wire. Then the anode of the blue jump LED with the positive rail of breadboard using red jumper wire, and the anode of yellow LED also to the positive rail of breadboard using a red jumper wire. Here your circuit connection for parallel connection is done. As soon as you connect the last jumper wire, you will see that all the three LEDs are turned on. Now starting from here, let's just check the path for current to flow through. If current is coming from here to here, see, in this hole, these holes are internally connected, so the whatever the current flowing through this can also flow through this and can also flow through this because they are internally connected. So from here onwards your current has two other paths to flow through rather than just this one. So either your current can flow through this, it can also flow through here and flowing from here. So your current has three different parts, means the current flowing through this, current entering to this will be divided into two other paths also. So in parallel connection, your current has more than two paths to flow through. Now, what happens or the advantage of this parallel connection is either the current flowing through this is coming to this point, and if this circuit has some fault or this particular section of circuit has some fault, so the current flowing through this will not affect the current in this section and current in this section because the separate current is flowing through this and this. So the faulty effect of this section would not affect the other remaining two section of the circuit. Hence the parallel connections are widely used in home and commercial wiring. For example, your LED, fan and TV, they are connected in parallel. In parallel, these are the different loads you can assume as in your home. So if just assume that this is your LED, this is your fan and this is your AC. So if fault in LED, if there is any fault in LED would never interrupt the current through this. If we have connected these three elements in series, then current or fault in any one of them would interrupt the current through the later elements of it. But in parallel, this is the advantage that it never affects the other two or a other number of circuits after it. So these are the connection steps for Tinkercad circuit. In home page of Tinkercad, click on new and then circuit and rename it as LEDs in parallel. Collect all the components from the component section. Connect the positive rail and negative terminal of battery with the positive rail and negative rail of breadboard respectively. Connect the cathode of all the three LEDs to the ground via 470 ohms resistor for each LED using a black jumper wire. Connect the anode of all the three LEDs with positive rail of the breadboard via a red jumper wire. The circuit connection is completed here. Now it is time to simulate the circuit and see the glowing of LED and observe the result. Now let's open first Tinkercad, create on click and then circuit. So, so in this we are building a circuit for LEDs in series. So just change your project name as LEDs in series. Now collect all the components we will require to build the circuit, which is breadboard, power source, three LEDs. So just keep in mind that we are connecting LEDs in series. So we will require only one resistor and three LEDs. So here we are changing the LED colors. Click on LED, then go to color and change the color. Yes. So you have changed the color of your LEDs. શું છે હું અહીંયા વિડિયો બનાવું શું જોઈએ અપ્પા શું જોઈએ બહાર જ હશે ને તમે તો અંદરના રૂમમાં ક્યાં આયા જ છો આજે પલંગ ઉપર હશે So let's just place all the components in its places. First is breadboard, then 9-volt battery. Connect the negative terminal of battery with the negative rail of breadboard and positive terminal of battery to the positive rail of breadboard. Change the wire as positive for with red wire, negative with black wire. So your power supply connection is done. Place a resistor somewhere here. Now place the LEDs in line. First here, second is here, and the third green LED is somewhere here. Now in series connection, what happens is each and every component which are connected in series, they share only one common node. So in series connection, we will connect this anode of the red LED with the cathode of yellow LED. So let's just join them. Now the anode terminal of this yellow LED is going to connect with the cathode of green LED. So this is cathode and I am going to connect. So these internal connections are done. Just to change the color of cable. Yes. Now the cathode of this red LED will go to negative rail of breadboard using a resistor or via a resistor of 1 kilo ohm. So connect the remaining terminal of this resistor with the negative of rail of breadboard and change the color with black wire. Now we have connected a circuit to ground. Now it is time to give this circuit a power. So we will power it with connecting this anode terminal of green LED with the positive rail of breadboard. So this is how we have given a positive to circuit, and also with this black wire we have given it to ground. So in the circuit the current will flow from here to here, then here, then here, and from this it will go back to the battery. So this is how your series connection is done. So now our circuit for LEDs in series is completed. So it's time to simulate your circuit. So go and click on to start simulation, and you can see all the three LEDs are glowing. Stop simulation, LEDs off, start simulation, and LED starts. So this is how LEDs gets connected in series. Now we will see this LEDs in parallel connection in Tinkercad. So to make a circuit in Tinkercad, first open your Tinkercad account, then click on to create and then circuits. So first I will change the name of this circuit as LEDs in parallel because we are using LEDs parallel connection. Now collect all the components from component section first. These are the resistors which prevents LEDs from overcurrent to limit the current. In short, this is the power source and this is the breadboard which is we are using to mount our different components together. So first let's just change the color. I'll change it to blue and it's yellow. Place first red LED, then blue LED just after it, and a yellow LED after blue LED. Now connect the negative terminal of battery with the negative rail of breadboard and positive terminal of battery to the positive rail of breadboard. Change the wires color black and red. Now what happens in parallel connection is in parallel connection the elements share more than two common nodes, means they shares minimum of two common nodes, but it may have shared more than two common nodes. Now we are using 470 ohms resistors, so just change the value of the resistors with 470 and ohms. Similarly 470 ohms. So I've changed the value of resistors. Now first, what we will do here is we will connect the anode terminal of all the three LEDs with the positive terminal of breadboard using a black jumper wire, something like this. So this is the anode of yellow LED and connect it with the positive rail of breadboard using a red jumper wire. So half connection of this is done. Now place all the three resistors something like this. First is here, second is here, and the third one is here. Place all the three resistors in such a way that there is one terminal goes to the cathode of each red, yellow, and blue LEDs and connect the remaining terminal of all the three resistors with the negative rail of breadboard. So I'm connecting this negative terminal of breadboard with other terminal of the resistors. Now change the color to black. Okay. Here your connection for parallel LEDs is done. Now it's time to see the result. That in here you can see that the current has path more than one path. If it can flow through here, also it can go through here, and also it can go through here. So each and every element in this connection has its separate current path. Means the yellow LED has its own path for current to flow through, this blue LED has its own path to flow through, and this red LED has its own path for current to flow through the element, or in this case LEDs. Now after connecting it, we will click on the start simulation. So just click on to start simulation and you can see that all the three LEDs has turned on. So this is how your parallel connection gets done. If you want to see something, then you see if you are increasing the value of resistance, the LED gets dim. See, again I am changing the value. See, you can see that the brightness of LED is decreased, has decreased. And now if I'm changing it to 1 kilo ohm, 1 kilo ohm, see, you can see that the LED is similar for this. If I'm changing the value, see, the brightness of it is decreasing. So by increasing the value of resistance in the path of current, the LED's brightness decreases. Similarly, if you are decreasing the amount of resistance into the path C, you can see that this suggesting of burnt out. Why? It is written in the box below it, which is current through the LED is 806 milliampere, while absolute maximum is means allowable, maximum allowable value of current is 20 milliampere, while the current right now flowing through this LED is 806, which you can say 20, which you can say 40 times more than its required or allowable maximum value. Hence the current in this path is so less, hence it is damaging the LED. Hence you are required to provide a specific amount of resistance in order to maintain the lifespan and also to maintain its brightness. Hence I'm changing it to 470 ohms, and each LED has its own different ohms to which it brights or illuminates the most. So this was the parallel connection of LED. So, welcome all of you. Today we are going to learn how to interface a push button using a Tinkercad circuit. So, to make a circuit in Tinkercad, first of all, open your Tinkercad account. Then click on to create and then circuit. So, it will open up a new blank page in which you are going to make a circuit. So for this circuit, you are going to need a one LED, a resistor. We are interfacing push button, hence we will need a push button, a breadboard to mount all this equipment onto it, and a power source, which is our 9-volt battery. Now, first of all, connect the negative terminal of battery with the negative rail and positive terminal of battery to the positive rail. Now I'll just quickly change the color. This is red wire and this is black wire. Now here you can see this is a push button. So in push button there are four terminals available, means four legs to which you can connect different things. So this is 2B, this is 2A, this is 1A and this is 1B. So in this there is 1B and 1A which represent 1 and 1. So they are both internally connected, and also this 2B and this 2A. These both twos are internally connected. So they are vertically connected, this one and this one terminal. They are just differentiated by A and B. Similarly, this 2A and this 2B. So anything you connect here and here, they will be internally connected and there will be no separation of this contacts, you can say. So in order to use a push button as a switch, we have to always keep this and this terminal in use. So you can fulfill your purpose of switching. So I'll explain you later in circuit in details. Now just change the color of LED by clicking onto it and then clicking on this drop down menu. So I'm gonna use a green LED in this particular session, and In this, I will change the value of resistance, which is 470 ohms. So just erase that and type 470 and ohms. So I'll change it by ohms. So this is how I have made separate specifications. Now first place the LED here onto the breadboard. Now I am connecting, see, this is the anode and this is the cathode. This cathode terminal will go to the negative of rail, and by this connection you will be connecting it to the negative terminal of battery. So place this resistor in such a way that it's one of its terminal, it is terminal 2, terminal 1, you can connect the either terminal, one terminal with the LED's cathode. So if I connect a cable, or if I don't connect, it is same, you can connect it with cable, or you can just put it here, because this each and every hole in this column, they are already internally connected. So they are connected in this manner, they are in this manner, not this and this, but just this column. And similarly you can say whatever I'm connecting here will goes up to this. So I have placed this resistance here, hence they are connected already. So don't need to use an external wire for it, you can use it and you can also not use it. So one terminal goes to the cathode and the another terminal of same resistor would go to the negative rail of breadboard. So for this you will have to connect a wire, because there is no internal connection, so you have to provide a path for current to flow, and hence you are using this cable to provide the path. So I will change the color to black, as it is a ground connection. Now what I want to do here is I want to switch, I want to control this LED by switching it. In the previous session we have seen the LED turning on only connecting this with positive and negative. So what happened in that is you have to disconnect each any of this cable in order to turn off that LED. But without doing that connection replacement, just we are placing a switch to control this switching operation. So we are just connecting this push button to turn on or turn off your LED as per the requirements. So place the push button in such a way that one B terminal of your push button connects with the anode of the green LED. Now, as I mentioned earlier, use a diagonal connection first. So this is 1B and its diagonal would be a 2A. So connect the 2A terminal with the positive rail of breadboard, because we have to give it power source for its operation. So we just provided the positive power supply to the push button, and through the push button it will flow through your LED whenever you press the push button or whenever you turn on the switch. Now, as we have seen in the switches lecture, that a switch is there to provide, to interrupt the current, or to current to let it flow from the path. So this switch does nothing but it opens or closes its contacts with external circuit. So in this case, this is the external circuit, means this load we want to turn it on or off, to in short we want to control it. So this switch is providing that function, means it is connecting it with external circuit, and as per a requirement it is breaking the contact with this external circuit in order to turn off this LED. So whenever you press this push button, it makes the contacts, or it makes the circuit providing a current to flow through the load and turning it on. So let's just see the operation. Now we have completed the connection. So to see the result, we will have to click on to start simulation, but before that we will change the name of our project. As we all know that by clicking on Tinkercad it has its random name, so you will have to change the name. So we will write a name as push button interface, or you can also use this that switching of led switching of led with push button. So you are turning on and off your led using a push button, hence you can name it in either way. Now, as we have completed our connection steps, now click on to start simulation. As soon as you press start simulation, you can see that your led hasn't turned on. Why? Because switch right now is in off state, means it has breaked its connection or contacts with this external circuit, means there is no a continue path or path without interruption for current to flow from here to here. See, current is in here with this terminal, but after this point it is not connected to it, so it has no path to flow through this, and hence there would be no flow of current in this led, and hence your led is in off state. Now as soon as you press the push button, now this push buttons close condition, or you can say the switch is on state. Switch is on, hence your load connected onto it, here your load is led is started, means you're pressing your push button enables the making of with external load circuit, means as soon as you press the push button it makes its contacts with external circuit, providing a uninterrupted path for current to flow through, means it provides a conducting path for current to flow through the anode and cathode terminals of led. Hence, it turns on the led, and with unpressing it, it turns off the led. Now, as I said earlier, that if what if you connect this 1B and 1A terminal? Now, let's just see. I am connecting this 1A terminal with this. Now, let's see what happens. Now, click on to start simulation, and as soon as I have clicked on start simulation, your led is turned on. So there is no purpose of push button over here. Without pressing it, it starts flowing current because these two terminals are internally connected. Hence the current, whatever amount of current is flowing through this, reaches here, and as they are connected internally, the current has a path, uninterrupted path to flow through this. To here, we have connected this terminal to the anode, and hence current reaches to anode and then cathode, and then going back to the battery's negative terminal. Hence it is a closed loop, and hence current flows turning the led on. Hence you have to have connect the push buttons diagonal terminals in order to operate it as a switch. So here is the interface of push button completes. Thank you. So after series and parallel connection, our fourth and last part of this session is about slide switch and RGB LED. So in this particular section, you will learn how to connect a slide switch to simultaneously turn on and off the devices connected to it, and how to connect RGB LED and how to turn it on. So first we will see controlling LED using slide switch. So first of all, what is a slide switch? So in the tutorial of switches, we have seen the different types of switches, and in one of them is a slide switch. So slide switch is a one type of switch, as the name suggests, sliding it from one side to other, you can control the lights or any devices connected to it simultaneously. Means sliding it towards any of the devices you can turn the particular device. It is a three terminal device having middle point as a common node. So in slide switch particularly, it has three terminals, and the middle one terminal is acts as a common node. For this experiment or activity, you would require a breadboard, a 9-volt battery, some jumper wires, two LEDs, two resistors, and a slide switch. So this is a pictorial representation of slide switch. So this is how your slide switch looks like, and there is a vertical knob to slide it from here to here, and it has three terminals: terminal 1, terminal 2, terminal 3, and the middle terminal acts as a common node. So this is how your circuit diagram looks like. Whenever you connect two devices, or in this particular case we are connecting two different LEDs with a slide switch, and we will control these LEDs using a slide switch. So for this connection, what you will do first is you will place your breadboard and slide switch as seen in the image. Then in the left side of the slide switch you will connect blue LED, and right side red LED. Now this common terminal of slide switch will go to the positive rail of breadboard. Now the battery is connected to the battery's negative terminal is connected to the negative rail of breadboard, and positive terminal of battery is connected to positive rail of breadboard, and the common node of slide switch is connected also to the positive rail of breadboard. These terminal is connected to the anode of blue LED, and the other terminal of slide switch is connected to the anode of red LED. Now the cathode of red LED is connected to ground, or is connected to negative rail of the breadboard via a resistor. Similarly, here slide switch blue LED's cathode terminal is connected to ground, or you can say negative terminal of breadboard via a resistor, and this is how your connection gets completed. So using the slide switch, one can turn on and off two devices simultaneously by sliding it both the sides. So first what you will do is, in the home page of Tinkercad, click on the new and then circuit, and rename your circuit as LED control using a slide switch. Collect all the components from the component section. Connect the positive terminal of the battery to the positive rail, and negative terminal of the battery to the negative rail of breadboard using red and black jumper wire respectively. Connect the middle or common terminal of slide switch to the positive rail of breadboard using a red wire. Connect anode of both the LEDs to the remaining both the side terminals of slide switch one by one. Connect the cathode of both the LEDs to the negative rail of breadboard via 470 ohms resistors, particularly using a black wire. Now here your circuit is completed. So this is how your circuit gets completed for a slide switch. Now sliding it to this side will turn on the blue LED, and sliding it to right side will turn on the red LED. So you can simultaneously turn on and off each of them as per your requirement. Sliding it to the left, the blue LEDs turns on, and sliding it towards right, the red LED turns on. So this was about a slide switch connection with two devices. Now let's see turning RGB LED on. That how you can use how can you connect RGB LED and turn it on. First of all, RGB. In the LEDs particular session, we discussed the different types of light emitting diode, and one of them is RGB LED. So RGB LED is red, green and blue. It is a single LED which is capable of producing three different lines in a one single LED. So at a time you can turn on either red or green or blue light from a single LED. meaning it is a 3-in-1 LED. 4 terminals LED. It has 4 terminals, one common anode or common cathode depending upon the module you are using, and 3 terminals for R, G and B connection. There are two types of RGB LEDs available in the market. First one is common cathode type. There is a cathode in common which will be connected to ground or the negative terminal of source, and the other three terminals will be fed to positive terminal of source. While in common anode type, there is a common node which will be connected to positive terminal of source, and the other three terminals will be grounded. So these are the two types of RGB LEDs. This is a pictorial representation of your RGB LED. First is common anode type and the second one is common cathode type. This in this common anode type, this anode will be would get connected to the positive supply, and these three would be connected to ground. While in this common cathode terminal would be grounded, this common and this common. The common anode, it has a common anode, and this common anode would get connected to the negative or negative terminal or to ground, and these are connected to red, green and blue to a positive supply. To perform this activity, you would require a breadboard, a 9-volt battery, some jumper wires, one RGB LED, 3 resistors and 3 push buttons. So this is the circuit diagram of your circuit. This is a breadboard, this is your RGB LED, these are 3 different resistors, these are 3 push buttons, these are jumper wires and one 9-volt battery. So first of all, place your RGB LED similar in this diagram. Now this is a common cathode RGB LED. Hence the common terminal of this RGB LED would be grounded. So first of all, what you would do is you would connect the 9-volt battery to breadboard. So negative of battery goes to negative rail and positive of battery goes to positive of breadboard. Now common cathode is connected to negative terminal of breadboard, and this is R, G, R, G and B. So these three terminals would be connected to the positive rail of breadboard via a resistor and a push button. So here is a resistor. Resistor is connected to this one terminal, and in a diagonal there is a jumper wire which is going to connect it to the positive rail. Similarly, the one end of a resistor would go to the RGB LED, and the another terminal of this resistor would go to push button. The push button's diagonal terminal would go to positive rail of breadboard. Similarly for this. So this is how your circuit connection happens. So on the home page of Tinkercad, click on new and then circuit and rename it as RGB LED blink. Collect the components from the component section. Now connect the positive terminal of battery to the positive rail and negative terminal of battery to the negative rail of breadboard using red and black wire respectively. Connect the common cathode to the negative rail of breadboard using a black jumper wire. Connect the 1B terminal of all the 3 push buttons to the remaining 3 terminals of RGB LED using jumper wires via a resistor. Connect 2A terminal of all the 3 push buttons to the positive rail of breadboard with red jumper wire. Your circuit for RGB LED connection is completed here. So in this particular type, what will be shown, what will be your result is whenever you click or press on the respective push button. So by pressing this push button, your LED will turn on but with red light emission. Whenever you press this push button, you will see your LED is emitting blue push button or blue light, and whenever you will push this press button, your LED will emit green light. So this is how you can see red, green and blue, three different colors in a single LED. So this is the purpose of RGB LED. They are used in decoration, decoration lights, and mostly for decorative purpose. So this was all about our today's activity session. Thank you so much. We will see you in next tutorial. So here we are going to make a slide switch circuit to simultaneously turn on two LEDs connected onto the either terminal of slide switch. To create the circuit, first open up your Tinkercad account, then create and then circuits. Now first change the name by slide switch LEDs on and off with slide switch. Okay, so I've changed the name. Now collect all the components from components section. First is a breadboard, then a power source which is a 9-volt battery. Then I'm going to use two LEDs. For them there are two resistors and a slide switch. So I'll just type slide and find the slide switch. So I will use the one LED blue and the another one is red. Now first place the slide switch over here. Now place your blue LEDs on the left side of slide switch and red LED. I'm going to just flip its terminal. So if you can see that by just clicking onto it means mirror component, you have to just change the terminals. So just click onto it means first anode was here and cathode was here. Now after clicking it, anode and cathodes are switched. Here anode is on right side right now and cathode is on left side. So just see that I'm clicking on to mirror component and see anode is on now, and anode is on now right hand side and cathode is on left side. So this is how you can change or flip over the terminals using that mirror component. So place both the LEDs like this. Now I'm changing the value to 470 ohms. So 470 ohms. Now in the slide switch, as you know that there are two terminals and there is a common terminal. So the common terminal is either you can connect it to uh, ground or you can connect it to the uh, power supply or the positive of this power source. Now place both the resistors. The first resistor is between the cathode terminal of blue LED and the negative terminal of rail. So first just connect this negative terminal with the negative of breadboard and positive with the positive terminal of battery. Change the color of wire to red and black. Change this color. Now place the second resistors in such a way that its one terminal gets connected to the cathode of red LED and the another terminal to the negative terminal of negative rail of breadboard. Change the color of the wire to black and connect this common terminal to the positive rail of breadboard. Hence as it is a positive. Now as you can see that we have provided a switch with power source. Now it's time to connect our last wiring of this circuit. Here we have provided a cathode of this LED with the negative and this LED is cathode with negative. So we will have to connect now anode. So the anode terminal of this LED would go to the first terminal number 1 of slide switch, and the terminal 2 would get connected to the anode of red LED. So I just change the color of wire. Okay, so here positive connection to the slide switch and slide switch power supply, and this ground terminal is done. Now it's time to see the result. So to turn it on, we will click on to start simulation. So as you can see that in here, the whatever the knob or this button is, this side is in the right side of its module, so it is in the right side, so it is turning on the component connected to right side of it. So in this side we have connected our red LED, so red LED is in on mode, while your blue LED is still in off mode. So you can turn it on by sliding it to this side. So by sliding it to this side, it will turn off the red LED and turn on the blue LED. So you can switch over its knob, and you can switch on one and switch off the other load, whichever connected to it. If here you have connected something different, then it will be turned off, and the this part will be turned on. So whichever side your knob is will turn on that particular side of load. So this is how a slide switch is used to simultaneously turn on or off either side of the device connected to it. So switching on to the left side will turn on blue LED, and switching on to right side it will turn on the red LED. So this is how a slide switch is used to control two devices at the same time. Here we are going to make a socket for RGB LED. So let's first open your Tinkercad account, then click on create and then circuit. Now first change the name of your project with LED turning on a RGB LED. So you are turning on RGB LED. Hence first collect all the components. First a breadboard, then a power source of 9-volt battery, three different resistors, three push buttons, and one RGB LED. Okay. Now I will change the value of resistance, which are 500 ohms. The another one as 600 ohms, and the another one is 700 ohms. Okay. Now first let's see, this is a RGB LED. It always has four terminals, three for particular three colors. R means red, G for green, B for blue. So this for these three terminals, and the another one is common. See, there are two different types of RGB LEDs are there. First one is common cathode and another one is common anode. In common anode, the common terminal is connected or gets connected with the positive of battery, and in common cathode type RGB LEDs, the common terminal of RGB LED gets connected to the negative of battery or grounded. Now here when you click on when you move point your cursor over here, you can see that this terminal is for red, means this is produces this terminal produces the red color. This is suggesting me that this is cathode, means this particular LED is of common cathode type. Hence this terminal would get connected with the negative terminal of battery. This is for blue and this is for green. So these are the four different terminals of RGB LED. Now place RGB LED something like this onto breadboard. Now connect the positive terminal of breadboard to the positive of battery and negative to the negative of battery. Change the color of wire. Okay, so you have connected your source with breadboard. Now what we will do first is we will connect the cathode. As we know that this is the common cathode type, hence I would connect this common terminal with the negative of rail. Hence it is connected to the negative of battery. Now place a resistor of 500 ohms here. Means your red terminal is connected to this terminal. Now place push button here. Something like this. Okay. And a diagonal terminal, so one terminal of this resistor of 500 ohms is connected to the red of LED, and the another the now we will go for a diagonal connection. So connect this diagonal connection with the positive rail of breadboard with a red wire. Now place another 600 ohm resistor and first this 700 ohm resistor here to the blue terminal of RGB LED. Place a push button here. In this way that its 1B terminal gets connected to the remaining terminal of the 700 ohms resistor, and its second terminal is with blue terminal of RGB LED. Now the diagonal terminal or diagonal, it is 1B, hence connect the 2A terminal with the positive rail of breadboard. Now place your third push button here and connect its 2A terminal with the positive rail of breadboard. Now connect this resistor's remaining terminal with your last terminal, which is green of RGB LED, and change it to the green. So here your connection for the RGB LED is done. Now to check or to turn it on, click on to start simulation. So as soon as you press a push button for red LED, so this enables you with a red color. So I am pressing this push button. You can see that your LED turned on with producing a red light. Now as soon as I press this button, your LED illuminates in blue color, and it is for green LED. Hence, this is a single LED which is capable of producing more than one color. So, by pressing it, it will produce red color. Pressing this push button will produce blue color, and pressing this push button, it will produce a green color. Hence, your LED is called as RGB.